All right, guys. For slide 3, we're now looking at amino acids. And amino acids contain two functional groups. One of them is an amine group. The other one's a carboxylic acid group, hence amino acid. Um, the amine group is usually on the alpha carbon, which if we look over here at the notes, here's an amino acid. There's your amine group. And then you have this carbon here. And the alpha carbon is the carbon right next to the carboxylic acid carbon. And so here is our alpha carbon. R can be a lot of different things. Okay, so there's a lot of different amino acids out there. There's actually, we're going to skip down here for a minute. There's 20 amino acids that you need for proteins. We make 10. And so there's 10 amino acids out there that are called essential amino acids, and you can get them from you need them from your diet. The good news is if you had a single peanut butter sandwich, you get all the amino acids that you need. So it's not very hard to get in the diet, but you do need to get those 10. So here's our amino acid. The R group is on the alpha carbon, which is the first one. Um, and so an example of an amino acid is glycine. This is the simplest of all the amino acids. You just have a hydrogen as your R group. This is very straightforward. And this is an amino acid. We usually draw them like this with the NH group on the left and the carboxylic acid group on the right. That's how I'm going to draw them. All right. So the R group, that's a side chain, and it may have functional groups as well. There might be an alcohol group on there. There might be another amine group on there. But this H2N and this COOH, those are vital. Amino acids do something else as well. They create what's called a zwitterion, which is a really fun word to say. What that means is your carboxylic acid group that has an acidic hydrogen, which means that hydrogen is going to get booted off. Um, and the amine portion is a base, which means it will accept hydrogen. So what you end up doing is creating this. You don't have two neutral ends to the amino acid. You get a negative end where the carboxylic acid has lost its hydrogen, and you get a positive end here where it was an amine group and it's gained a hydrogen. So this is how Zwitter-ions look, and that is how we're going to draw them. That is the way that we're going to look at. All right. By ionizing itself, it allows it to dissolve very easily in water, very important for human beings, and it gives them a higher melting point. So this is all good news. Uh, this is, like I said, the primary form of amino acids. Page 750. You have to go to page 750. I will be referencing this page. You need to look at it. If you print it out, that would be great, but you need to have that in your possession. 750 is going to be a page that we look at quite a bit. I already talked about these essential amino acids in your diet, and we're going to use the 3-letter abbreviations. So there's 3-letter abbreviations that work with all the amino acids, and we're going to be using those because it's just simpler than saying glycine and isoleucine and leucine and all of these other ones. So prepare to use those 3-letter ones, and you need to reference page 750. That is going to be very important.